Hi there, nice to see you. I'm actually going to start off just with the Olympics thing because it's something that hopefully everybody can find generally interesting. And then we'll go into the active logging thing, which is maybe a little bit more of an education for some people. So essentially, just to give you some background, Sienna is a digital media infrastructure used by a number of news and sports broadcasters, and it's been quite significant in the Olympic Games. It was the second biggest system at Beijing, and it's going to be used in a very interesting way at the London Olympics. Basically, just briefly introduce myself and the company. We're a UK-based company. We've been doing broadcast and other media innovation since 1992. The Sienna media infrastructure is our primary end-to-end digital media system that's used by news, sports, entertainment, and also now next-generation broadcast infrastructure. It's all Macintosh-based, so we've leveraged the whole Macintosh platform with QuickTime and the editorial and so on that comes in it, and produced a real world-class mid and high-end broadcast infrastructure. Route 6 is our UK integration partner, and they've done quite a lot of very interesting projects with Sienna. Our customer base, generally speaking, we appeal to the mid and the high end of global broadcasters. So companies like the BBC, Associated Press, Sky, and other global broadcasters of that kind of ilk. We tend not to do kind of low-end projects because our system is kind of priced mid-end, but it's got very high-end functionality, so it appeals to the mid and high end. So I'm going to briefly go through and talk about sports broadcasting, and in particular remote sports broadcasting. This is the bit that's different that we're going to talk about, is the idea of rather than sending your entire crew and all of their equipment from, in this case, Mexico all the way to London, we're going to talk about how we could cut down on that logistically and send a much smaller crew, leave the rest at home and work remotely on something as large as the Olympic Games. We're going to talk about the challenges involved in doing that over a wide area network. We'll talk about our solutions for that and also how the workflow actually runs together. And then we'll take a quick look at the actual hardware of the Olympics rig. Okay, so first of all, sports broadcasting is everywhere, every day. In every major city, there's usually at least one important sporting event. So it's absolutely everywhere. And so for a sports channel, you simply can't cover everything. You've got to cover the things that appeal to your audience and the things that you can afford to cover. Obviously, it would be nice if they could cover more events. You'd have more diversity of sport on screen, and also if they could cut the cost of covering major events, that would also be really useful. And of course, if they can cover more events, you start to bring in niche sports, which are quite interesting to maybe a smaller market, but maybe a larger market if it were covered nicely. So we're going to try and reduce the cost of covering sports. Major expenditure for things like the Olympics are, if you've got to send 50 or 60 editors to England to live for a month, you've got their airfares, you've got their accommodation, and then you've got the hidden cost, which is you've got to build them an edit suite each. So you can see that just by sending your editors, forget all the other infrastructure, you've already landed yourself with a pretty enormous bill. And those people have got to be away from home. You know, some people like traveling the world, but a lot of people actually don't really want to go and live in another country for a month. Also, the other thing which was very interesting in London, conversely to Beijing, in Beijing the Chinese broadcast centre was enormous, and our customer Televisa could have as much space as they wanted. And they built 2 giant studios and they had a huge gallery, and they could have as much space as they wanted. In London, the space is really a premium, and they've basically got a porter cabin to do their entire broadcast infrastructure. So they haven't even got the space to house all those people because the space in the London Olympics is so small. So what can we actually make remote? Well, what we're going to do is one of the biggest labour efforts in sports is logging. So you want somebody to sit down and literally log everything that's happening in every live event, and there's going to be lots of simultaneous live events. So what we're going to attempt to do is have the loggers in Mexico. The other thing we'd like to do is have as many editors as we can off-site as well. So we're going to try and have a work at that. And as I said, the operators will work at their own desk and sleep in their own bed. So the infrastructure that you're going to use already is there. You're not going to have to build anything new. You're not going to have to move anybody. You can imagine the cost savings simply by doing that. Logistics and infrastructure. Surely it can't be that simple. Okay, well, the answer is it's not that simple, and that's why not everybody does it. And there are very few broadcasters that can actually do a proper, full-scale, end-to-end remote sports coverage. One of the biggest challenges is latency in the wide area network connection. So let's assume that you can get yourself a 100 megabit connection from London to Mexico, which I understand is quite expensive. Although ironically, in Mexico itself, you can get 100 megabits down and 100 megabits up for $80 a month. But in England, you certainly can't get 100 megabits up for anything less than a small fortune. So we're going to have a 100 megabit connection, but what we'll find is from London to Mexico, we've actually got about 250, 300 millisecond latency. And that is what absolutely destroys your network connectivity. So the problem is with latency is that with Ethernet, it's sending small packets, and often those small packets via TCP/IP have to be replied. So you send a package, it takes 200 milliseconds to get there. Somebody then says, okay, I got that, 200 milliseconds back. You've sent one packet in 400 milliseconds or something like that. You can see how, if those things are serialized, it doesn't matter how much bandwidth you've got, the latency, which is the bandwidth delay product, ends up defining what your bandwidth is. You can throw more bandwidth at it, you'll only get a tiny bit more performance. So the latency is everything in this wide area network stuff. The latency has the biggest effect on TCP protocols, which are most of the ones you'd normally use. So all of your file sharing protocols, SMB, AFP, CIFS, even HTTP and FTP, they're all using the TCP protocols, and that's the one that suffers significantly from the latency. And as you can see, typical file sharing might drop from 90 megabits a second in your local network on your 100 megabit connection to less than 1 megabit a second once you've got 200 milliseconds of delay in there. And at 1 megabit per second, it's really not very useful at all. So you can see how this latency is a huge challenge to this remote operations. What we're going to try and do is remote editing and remote logging. And I'll also tell you now why traditional WAN file transfer software won't help. So you're probably all familiar with things like Aspera and Signient. These are softwares that get around this WAN latency issue using things like UDP protocols. But mostly they're generic file transfer boxes. So they'll expect you to dump a file in a folder somewhere. It'll take care of moving it across the WAN at high speed and then dumping it in another folder at the other end. The problem with that is that we need to do all this stuff in real time. So we're actually going to be ingesting, and as we're ingesting, we need the files to be moving across the WAN as they're ingesting so they can be logged live. And we're using things like QuickTime reference movies, growing QuickTime files, and all sorts of things that the traditional WAN transfer products like Aspera and Signient simply weren't really designed to handle. They like a nice finished closed file they can grab a hold of and move. We're actually going to be moving essence as it's happening in real time across the network. So what we've got is Sienna Media Vortex, which is our WAN transfer tool. And rather than being generic, it's highly integrated. So it understands exactly what we're trying to do, and it can work with all of these dynamic growing files. So we're going to be ingesting files with Sienna Picture Ready, which is our baseband ingest tool. That'll be creating a QuickTime reference movie on our storage in London, which will be a reference and then audio and video essence files that are growing constantly as they record. All of that gets handed to Media Vortex as soon as we initiate the ingest. And Media Vortex understands QuickTime reference movies, and it's actually going to shift that data across the WAN connection in real time as it's recording without doing anything wrong. The other thing it does, very important, is it reconnects the references at the destination. So rather than copying a reference movie across to Mexico, and then when you open the reference movie, it's actually trying to talk to the London media, it's intelligent enough to know that, yeah, we should repackage that movie so that it knows what it's talking to locally. It's also very tightly integrated with the Sienna Media Asset Manager, and that's the critical bit to the workflow, because we start the ingest. By the way, we're going to be controlling the ingest remotely as well. So somebody in Mexico has got visibility of the ingest ports in London. They're going to hit record. That's going to automatically hook up with the Media Vortex, and then within about 20 or 30 seconds in Mexico, they're going to start seeing the media arriving and actually start logging it, and it'll be installed in the MAM there as well. So they'll get full media asset management of those assets, even though they're actually creating remotely. Scales well with parallel transfers. In fact, even better. Since they're going to be recording 20 ingests, it actually makes better use of the network because we've got 20 parallel connections. And you can pause and abort each transaction. So if you need to, you've got a limited bandwidth. If you do need to prioritize one or the other, you can do that. So how do we connect it all up? So we have this concept of the Sienna Distributed Media Cloud. What we've done there is, rather than use a traditional cloud model where essentially everyone tries to put something in the middle in one place which has a relatively slow connectivity to everything else, what we've done with the Sienna Distributed Media Cloud is look at the reality of broadcasters, which is they would typically have multiple big sites that want to be connected together, and there is no central cloud. So what we allow you to do is actually treat all those locations together as a kind of a virtual cloud in terms of giving each member of that cloud parity access to all of the other media. So we've got things like federated search. So in Sienna, you can actually do a search, and you can search, in this case, Mexico and London at the same time. But in the case of a larger broadcaster like the AP, where they've got 4 Sienna sites linked together, you can actually search all the media in all 4 sites. And when you find something, you can play the proxy, and if you need to localize it, it'll do it automatically. As soon as you try to bring that asset into your local editor and say, I know what's going on there, that's in the other site, we need to localize that high res first. Or in the case of Mexico, what I didn't mention is, because we've only got 100 megabits of data, it's simply impossible for us to bring all of the high res across. So what Sienna Media Vortex is actually doing is only bringing the proxy representation across to Mexico, and leaving the high res in London. And they'll be logging and editing with the proxy. And Sienna's got this concept of conjoined assets. I'll just explain briefly what that is. If you imagine you've got a high res and a low res in London, and we end up using Media Vortex taking the proxy or the low res over to Mexico, the important thing is to keep the connectivity between those 2 systems. And we have this idea of a conjoined asset, where those assets are actually duplicated, but they're conjoined so that each one knows about the other one. And a critical part of that is, when they're logging in Mexico using the Media Asset Manager, they're going to be adding log entries. So somebody ski jumping or whatever the games are, they're doing canoeing or whatever, falls in the water at 1 hour 10 minutes. That's going to go into the Media Asset Manager in Mexico against this asset. But because the assets are conjoined, Sienna automatically knows to propagate that information back to the London database. So every log line you make in Mexico automatically appears in the assets in London. So that on either side, editors can work regardless of which side. And it's bi-directional. If they log in London, it'll appear in Mexico. So you've got this conjoined mechanism where these assets are synchronized and actions are propagated to all of the other cloud members. When you finish proxy editing in Mexico, there's an automatic conform of edits at the event site. So they'll publish from here. It'll automatically say, you haven't got the high res, but I know where it is. And it'll actually publish the event over here. So we'll end up with a high res published where the high res exists. And they'll probably play it out. We've also got remote control of play out. So from Mexico, they can initiate an ingest. So basically, nobody's doing anything in London at all. They can initiate the ingest in Mexico. It'll be propagated across using Media Vortex. They can log it, they can proxy edit, and they can publish the high res. Again, nobody's done anything in London so far at all, other than watch for fires. When they finish publishing, there'll be an asset, and they can remotely load that asset into a baseband playout channel in London, and they'll probably play that out over a satellite in real time, or they can actually drag the finished asset all the way across to Mexico slowly with the high res. Although typically they'll be actually having a bulletin, probably a bulletin studio, and they'll do playout in real time from London. Let's see an example. Okay, so by the way, what I didn't mention is the other logging tool we've got, which is really nice, is this thing, Production Palette. This sits on a little iPad, and we've got one out there you can have a look at if you're interested. And as you're logging, you've got these grids. Now, this is a grid actually made for some live music TV show, but typically this would be a sports grid. So you'd make a grid for every sport. And those grids can contain keywords, if you want pictures and things like that, team members, so you can have multiple grids. And they basically sit on an iPad. So as you're logging, you've got a jog shuttle, you've got your proxy video that's trickling over from London, and you've got a touchscreen iPad. So it really makes it a very, very compelling and rapid and efficient logging mechanism. Scrub through, you can do chase playback. So as it's recording in London, you're doing a chase playback in Mexico. You're pausing, finding the bits you want. Somebody smiles, waves, and it's this bloke here. Carry on, next log. And as you do that, that metadata is propagated back to London or any other cloud members. So the whole thing is extremely tightly integrated. So just a little bit of history on this before I show you the actual pictures. So we were first consulted about remote ingest by the BBC in 2007 before the Beijing Games. At the time, they were planning to try and do a remote connection. It turned out that they couldn't afford the connectivity from China to London, and they didn't do it. But it basically brought us into the topic and allowed us to identify the problems. At the Beijing Olympics, Televisa had a very large Sienna system. It was the second biggest system in Beijing. The only largest system is NBC Olympics. So the Sienna system at Beijing, although it wasn't remote, was an enormous and significant system. All Macintosh-based, 200 terabytes of storage, 50 editors, 22 high-definition ingest channels, 8 playout channels, and so on. That system's been in Mexico City ever since, running Televisa Deportes channel. So it's been not only was it a good purchase for the Beijing Olympics, it's also proven to be a good long-term infrastructure they've used for their sports system. And as you will see, that system forms the Mexican half of this remote system we're going to do. So for the 2012 Olympics, they've built a second smaller rig, and this is the one that's going to travel to London. It's connected at 6,000 miles, 100 megabit connection with a 250 millisecond latency, as we discussed. And there's a Sienna MAM at each end that are going to do all this media propagation and conjoining and stuff. And they've got 20 channels of HD ingest, 4 channels to play out, and full remote operations. And this is what it looks like, in theory. Okay, so this is the system in Mexico, which is 5 or 6 racks of mostly storage, but they've got a whole load of ingest, they've got media asset management stuff. This is the system that was built originally for Beijing and is still going very nicely. They've kept it updated and kept it current and so on, and it still works very, very well. I think this was one of the control rooms in Beijing. Here's our ingest going on. They've got 22 ingests in record there, I think. This is the system they've built for London, and they've gone, obviously, with 4 years later, the technology moved on a little. And significantly, what they've done is they're using these new ingest and playout channels. So these are using the Mac quad-core i7 mini servers. We've got 2 there per U, and we're using the Thunderbolt connected IO XTs from AJA, a really nice unit. So in 2 years there, we've got 2 channels of ingest or playback. It's the same hardware, whether it's ingest or playback. Because they've got a history with fibre channel storage, they've continued to do that. And these systems also have the promised Thunderbolt fibre channel adapters that are connected. And they had a load of Xserves lying around, so they've used those for the core media asset management. And also they're using Sienna Taro, which is a very, very nicely integrated card-based transfer system. So this is taking their P2 material and has a very nice integrated way to get that into the system, also propagate that proxies over to Mexico and so on. So to summarise, sports broadcasting really needs remote operations. In order to minimise your costs, to cover more type of sporting events and so on, you need remote operations. And it's what everybody wants, but very few broadcasters can do it. You've probably seen in the news NBC Olympics are crowing about their big remote system. NBC have spent $1.1 billion on sporting rights for the Olympics. So you can imagine how much money they've got floating around to build their remote system to fill those rights. Televisa haven't got $50 million to build this system, and frankly they don't need it because the NBC system is achieving really nothing that the Sienna system isn't achieving. They've got a fatter pipe across the connection. They're probably paying as much for that pipe as Televisa paid for the entire infrastructure to do this. And their system is much, much more complex. It's a real kludge-up, mash-up between about 6 or 7 different manufacturers. There's lots and lots of little logistical kludges there, where Sienna is very, very slick and end-to-end. We've solved the latency and the management using the distributed media cloud and Media Vortex, and it will be used in the London Olympics at 2012 this year.